Double angle formulas. Oh, thank you for that comment. Somebody suggested that I write a little bit bigger. I'll try my best. Sometimes when I'm writing, I just forget that maybe it's too small, but I'll keep in mind, I'll be conscious about it. Now, before I go into the double angle formulas, I want you to remember the sum formulas. And let me get the formulas close to the camera so you can see it. This was written before I looked at the comment. So sine of a plus b equals sine a cos b plus cos a sine b, cos of a plus b, and so on. So let's copy those formulas. This was covered in an earlier video. Sine A cos B plus cos A sine B. Now, what happens if you replace both of them by theta? So, if you replace A by theta and B also by theta, notice on the left side, I'm going to have sine of theta plus theta. Look, theta plus theta is 2 theta. And that's why it's called a double angle. And notice what happens on the right side. So A is theta, which means sine A becomes sine theta. And B is also theta. So that's cos theta. Plus, this is cos theta sine theta. And we can simplify now. Theta plus theta is 2 theta. Now, in general, a plus b, you can't combine them, but theta and theta are like terms. And notice here also they are the same terms. Sine theta, cos theta. I have cos theta, sine theta, but it's the same as sine theta, cos theta. So it's the same term. Now here, these were two unlike terms because you have sine A cos B and that is a cos A sine B. If it was sine A cos B, then we could have combined these two, but they are not. But as soon as you switch, if you change both of them to thetas, now they become like terms. So they are the same, sine theta cos theta plus sine theta cos theta. So this is 2 sine theta cos theta. So this is our first double angle formula. Sine 2 theta is 2 sine theta cos theta. All right, now let's think about the cos A plus B formula. Cos A plus B we saw was cos A cos B minus sine A sine B. So it's important to remember the sum formulas. When you know the sum formula, you can derive the double angle formula because you can change both of them to thetas. Let's do the same here. Change both A and B to thetas. So then this becomes theta plus theta. And this is cos theta minus sine theta sine theta. And we can rewrite this. It's cos 2 theta and cos theta times cos theta. That's cos square theta. It's cos theta quantity squared, but we write that as cos square theta. And this we can write as sine square theta. It's sine theta times sine theta. So this is cos 2 theta. But notice that the expression on the right side involves cos square and sine square. Now, if you recall the Pythagorean identity, cos square and sine square are related by some other equation. If you change this minus to a plus, then cos square plus sine square equals 1. That was a Pythagorean identity that I urged you to remember in my earlier video. Now, there are so many things, you don't have to remember a whole lot, but a few things that you should remember, like the sum formulas and the Pythagorean identity. There are 3, but just remember sine square plus cos square equals 1. You can derive the other 2. Now, So let me recall that identity. Cos square is, or okay, let's write down the Pythagorean identity first. So cos square theta plus sine square theta equals 1, and this means that cos square is 1 minus sine square, and sine square is 1 minus cos square theta. So we can express cos square and sine square in terms of the other. Now that will give rise to two more identities for cosine 2 theta. So let's do that in a separate sheet. So let me rewrite what I had written in the box. Cos 2 theta equals cos square theta minus sine square theta. And this came from cos of a plus b formula. And also, if I write cos square theta as 1 minus sine square theta, then I can rewrite the cos square. I can change it to 1 minus sine square. And if it is a binomial, let me put it in parentheses. Sometimes the parentheses are needed and sometimes they are not, but let me put it if it's a binomial. And notice this simplifies to, you can simply remove the parentheses now and you get 1 minus sine square minus sine square. So this is 1 minus 2 sine square theta, because sine square theta, you can combine them. Those are like terms. So there's one other formula for cos 2 theta, and again, I could rewrite sine square as 1 minus cos square. And I can go back to my original formula cos 2 theta, and notice this time I want to rewrite sine square. I'll keep the cos square part, cos square theta minus, now this is where I definitely need the parentheses, sine square theta, because there is a negative sign outside. So this is cos square. So I'm replacing, oops, sine square is 1 minus, okay, I'm sorry. Let me rewrite this. This is cos square theta minus, that sine square is 1 minus cos square theta. So here I need the parentheses, and let me distribute the negative. It's cos square minus 1, but negative times negative is positive. So I am going to get plus cos square. So now you can see that I have one other formula for cos 2 theta. I can combine these two, write it as 2 cos square theta, and then minus 1. So you have three formulas for cos 2 theta. And again, these two formulas will be used later on to derive more identities. So we need all three of those formulas. And then let's talk about tan. If you recall, tan of a plus b, I said it's going to be a fraction, and the numerator looks like you're distributing tan. So it's tan a plus tan b. I mean, you're not distributing really, you can't, but just to remember, that's how you can get the numerator, tan of a plus b. It's tan a plus tan b, and the denominator is 1 minus tan a tan b. So again, if you replace both a and b by thetas, then the right side also becomes tan theta plus tan theta over 1 minus tan theta tan theta, which can be rewritten as tan 2 theta equals, now the fraction You can combine these two terms. They are the same. Tan theta plus tan theta is 2 tan theta. And the denominator is 1 minus tan theta is tan square theta. So we derived the formulas for sine 2 theta, cos 2 theta, tan 2 theta. But sine 2 theta was 2 sine theta cos theta, but cos 2 theta had three different incarnations. Cos square minus sine square, 1 minus 2 sine square, or 2 cos square minus 1. And then tan 2 theta is 2 tan theta over 1 minus tan square theta. And those are your double angle formulas. In a subsequent video, we will look at these two ways for these two formulas, and we will get what are known as power reducing formulas. So that's all for this video. I'll see you in the next one. Thank you.